Hello, welcome to the Data Structure and Algorithms online tutorial video. In last video we have learned about pointers, and in this video we will learn about queues. Let us have a quick look on overview of the things you are going to learn in this video. You will learn what is queue, operations of queue, types of queues and applications of queues. Let us first understand what a queue is. A queue is an ordered list in which it enables insert operations to be performed at one end called rear and delete operations to be performed at another end called front. Queue is a data structure just like a queue in real world, in which what comes first will go first. It follows FIFO principle, that is first in, first out. Queue can also be defined as a list or collection where insertion takes place from one end and deletion takes place from another end. We can take a real world example of a ticket counter in the cinema hall. Here you can see in the picture people standing in a queue for booking cinema tickets, and counter works on first come first serve policy, just like the queue's first in first out principle. Here is the representation of queue. As you can see, there are two ends of the queue. The end at which insertion takes place is called rear and the end at which deletion takes place is called front. Next we will see operations of queue. They are peak, queue overflow, isfull, queue underflow, isempty, enqueue and dequeue. We will see these all operations in detail one by one. The first operation is peak. It returns the element which is pointed by the front pointer in the queue but does not delete it. This function helps to see the data at the front of the queue. Here is the small algorithm to perform the peak function. The algorithm begins with the peak procedure and it returns the element pointed by the front. Here you can see in the algorithm it begins with the procedure peak. It returns the queue front value and after returning the value it ends the procedure. Queue overflow is full. It shows the overflow condition when the queue is completely full. If we are using a single dimensional array to implement the queue, we just check for the rear pointer to reach at max size to determine the queue is full. In case we maintain the queue in circular linked list, the algorithm will differ. Here is the algorithm to perform isfull function. First it will begin the procedure isfull. It will return true if the rear is equal to max size, else it will return false. First it will end if condition and then it ends the procedure. Queue underflow is empty. It shows the underflow condition when the queue is empty, that is no elements are in the queue. Let us see the algorithm to perform isempty function. First it begins the procedure isempty, returns the true if the front is less than min or front is greater than rear, else returns false, ends if condition and then ends procedure. If the value of the front is less than min or 0, it tells the queue that it is not at initialized, hence empty. The enqueue operation is used to insert the element at the rear end of the queue. It returns wide. That is why its operations are comparatively more difficult to implement than that of stacks. We should follow some steps to enqueue or insert data into queue. Step 1. Check if the queue is full. Step 2. If the queue is full, produce an overflow error and exit. Step 3. If the queue is not full, increment the rear pointer to point the next empty space. Step 4. Add data element to the queue location where rear is pointing and return success. Let us see the enqueue operation representation to understand it thoroughly. Here in the diagram you can see that the queue is having 3 elements before inserting a new element. 1, 2, 3, and 1 is representing the front end and 3 is representing the rear end, and rear end is the end where we insert the element, and that operation of inserting is called enqueue operation. Before inserting an element we have to check for the condition whether queue is having a space for inserting the new element or not, and that condition is called isfull condition. After checking the isfull condition we will come to know that the queue is having a space for inserting a new element, and after inserting the element the queue size will become 4, where 1 is representing the front end and 4 is representing the rear end. Here is the algorithm for performing the enqueue operation. As we have already discussed that the queue checks for the condition is full before inserting an element. If the condition is full, then it returns the overflow, and if it is not, then it will increment by 1 to add the data to the queue and returns the true. Dequeue operation, it performs the deletion from the front end of the queue. It also returns an element which has been removed from the front end. It returns an integer value. The steps to be taken to perform the dequeue operation are: Step 1. Check if the queue is empty. Step 2. If the queue is empty, produce an underflow error and exit. Step 3. If the queue is not empty, access the data from the front end. Step 4. Increment the front pointer to point to the next available data element. Step 5. Return success. Now let us see the representation of the dequeue operation and understand it cleanly. Here you can see in the diagram that before deleting any element from the queue is having 4 elements, that is 1, 2, 3, 4, and 1 is representing the front end and 4 is representing the rear end. As we already know that the end where we delete the element is front end. So here we can be able to delete the element 1 from the queue. Before deleting an element, we have to check the condition is empty. After checking the condition, we will come to know that whether the queue is empty or not. And after checking the condition, we will be able to delete the 1. Here in the diagram, you can see that the 1 element is deleted. The dequeue operation is performed. After deleting the element, the 4 will remain the rear end and 2 will become the front end. Here is the algorithm for performing the dequeue operation. As we already know that the queue will check for the isempty condition before deleting an element from the queue. Here you can observe in the algorithm if condition is checking for the isempty operation. If queue is empty, return underflow and end the if condition. Data is equal to queue front. The element is deleted from the front end and return the true. In the next video, we will learn about the types of queues in detail. Stay tuned with us, don't miss out on important topics. If you have not subscribed to our channel yet, please go ahead and subscribe it right now. And don't forget to hit on bell icon to get notified whenever we post new videos. Please install DSA application from the Google Play Store or from the link given in the description below.
Thank you for watching. If you have any queries, let us know in the comment section below.